Welcome to ShopBot Online Training, and today's topic is going to be a two-sided machine cut. So as you can see on my screen right there, there is a wooden propeller that would be used on an airplane, and we are going to be working on a file of a much smaller one, but since I have figured out a way to flip and do a two-sided machine, I've become really obsessed with propellers and trying to cut them. So I took a file for a propeller and I stretched it to 4.5 feet long, and then I did a two-sided machining on it. So that's, as you can see, is stretched to get along I have a 4-foot by 8-foot PRS, and that's going along the Y. So you can see that's a little bit longer than 4 feet. So the one we'll be working with today is a little bit shorter. It's approximately 12 inches, and that would be a perfect size for you to start out with. Today's model will be something that you could take this model and just go and buy a 2x4 and cut it down into 18-inch lengths and practice on that. That way it's all practice on something that's fairly cheap until you've got the system down. So that's kind of what we're going to go through. Let me show a quick set of pictures here to show you where we'll be going today, and then we'll step back and actually get into the training. So the way this started was a block of wood. This was a big chunk of poplar that I had, or popple, depending on where you're from, that I had in the garage. So I said I'm going to make the biggest prop that I can out of this piece of wood. And there's the setup. So there's a 4-foot by 8-foot machine, and the first thing you want to do when you get into two-sided machining is you want to have a flat table. You really want it to be nice and true. So you see right here, this is me surfacing the table, so I have a nice flat surface to be working on. Alright, next thing you do is you'll have your model, and you'll have to take and go into your model and do your programming as far as figuring out your sizes and your toolpaths and your orientation of the block. And that's what we're going to get into doing next. First thing I did here was I actually zeroed to the table, and I cut some indexing pins down into the table. Some 1/2-inch dowel pins is what I did. And the next thing I did after that was I took and I screwed my board down to the table. And here's where you see me now drilling those same, I went and re-zeroed now to the top of the board, and I'm drilling those same indexing pins in the top of the board. And you're going to see in a little bit, this will all make sense. I just wanted you to see the pictures first. So there it is drilling the other end. Now here it is starting to mill it out. So this is side one, and it's starting with a roughing toolpath. So I got a big 1/2-inch end mill in there just auging all that material out. And here it is, you can see more of the roughing pass. And now here it is starting to get into the finishing toolpath, where it's starting to give the nice precision in there. So there the machine's done with the first cut. Notice there's a hole on the top here and a hole on the top here. And notice that same hole that's right here is also right here in the table, and there's one right here in the table. So I'm going to be able to just take that prop, move it over there, flip it 180 degrees as far as from the face to the face, not from end to end. Do not do that. Do it from this face that was just up, now needs to be down against the table. And I'll put a little dowel pin in there, as you see, and that's where it's going to line it back up. So that dowel goes in there, and that holds it down. Then I rerun my screws, because the dowel pin is just for indexing. The screws are still my hold down method. And then there again I start loading the bottom side of the table. Or, I'm sorry, the bottom side of the prop. And here it is cutting out. And something to keep in mind, notice along here how I've got scrap wood along my edges outside. And I'm going to show you some pictures where when I first did this, something that I learned, if you don't have this extra wood out here and your bit's just kind of out here in no man's land, it can really grab some chunks of wood and throw them around like these out here. So I'll cover that again later. I just wanted you to take note that I've got a board that's wider than my model. And then there's the finished prop. That's pulled off the machine and just, sanded up on the ends to take the knobs off, the tabs off. And now I got to spend some time and sand it up and what I should have done too was drilled some holes and made it look more authentic, like it was a bolt-on part. So that's where we're going to go. We're going to do this on a little bit smaller scale, so that way you're able to take this file and then go practice it and do it on something, like I said, a 2x4 that you can go ahead and make some mistakes with, and it's not going to be very costly. So so what I'm going to be doing here is using a series of videos that I've already filmed, and I'm going to have those go along with the different trainings that, the different portions of my toolpathing today. So I've taken and filmed all these videos already on how to do this, and then what we'll do is we'll reference the videos back and forth versus having a live machine. We've all been to my trainings before, how the live machine goes when we record. So so today we're going to be using the software called PartWorks 3D, which is also known as Cut 3D off the Vectric website. So if you have purchased the software from us, it's called PartWorks 3D. If you've got it straight from Vectric, it is called Cut 3D. We're also going to be using VCarve Pro. And for some of you shopbotters that have had your machines for a year or two now, it's the same software as PartWorks 3.0 or 3.5. We just switched the name, and this is the version of it. So we used to call our software PartWorks 3.5 was our last version, and then we switched to just get rid of confusion of names, which actually has me twice as confused. But now it's just called VCarve Pro ShopBot Edition. So we'll be using these two softwares. And if you have Aspire, which is pretty much these two put together and a lot more other powerful options, you could also do this in Aspire. But this is what every ShopBot sold gets, is they get a copy of VCarve Pro and they get a copy of PartWorks 3D. So that's what I'm going to cover today, is what goes out with the machine. So for this, I'm going to go ahead and open up PartWorks 3D. And there is a training on our webpage. And let me just point out, too, where you can find these trainings is you can always go to our webpage, shopbottools.com, go to training, go to training tutorials and videos, and here's several of the trainings. So here's one right here that's just an intro to PartWorks 3D. It's where we go in and just do a regular 3D carving from one side. So that would be, if you're new to PartWorks and 3D, that would be the video to watch first, so you understand that. And we're going to take it to a new level today because we're actually going to flip it. So again, with PartWorks 3D, we actually have to take somebody else's file and bring it in. Somebody's already created a 3D file that we're going to bring in and scale it and toolpath it. So we're doing some work ourselves, but somebody has went ahead and created this file, whether it's something you've purchased, or like I said, if you're using Aspire, you're able to create your own 3D artwork, but you've got to be pretty good to be able to do that as well. So I will load this file, and I am looking for two-sided machining, and right here it's called section prop. So prop section, I go ahead and load that up, and it brings in the prop section. So this is the 3D model. See, somebody's already created this 3D model, and it's a two-sided part. So we will have to do a flip to be able to cut from both sides. We'll have to tab the ends so the part doesn't go flying out of there. We're going to have to tell the machine what bit, how fast to cut, and the most important thing is, how are we going to cut the first side and then flip it over 180 degrees and line it directly back up and cut the back side. So that's what we're going to get into. Deep breath. All right. So first of all, when you bring in your part, you got to figure out which way you're going to orient it. Since I cut this on a desktop at ShopBot, our desktop has 24 inches in the X and 18 inches in the Y. And I did it along the X because that was easiest for me to get to and easiest to video. So I can actually rotate this part inside the model. And now what it's done is it's put the long part in the X versus the Y. And that's how I want it for the setup that I've got videoed. So with this prop already has a specific size. That's the size of the prop this guy needs. This is an example of a shop botter who cuts model airplanes and needs a prop to a certain size to go into his plane. So this would be one of three, and then they have notice how it has a round end on it, and they all go into a central hub. So it's not like the propeller that I just showed you, my 5-footer. This is a different style, but it's the exact same thing as far as top and bottom two-sided machining. So we will go with the dimensions, because that's the dimensions. And right here, instead of sides of the machine, instead of just the top, you're going to see that we go and do the top and the bottom this time. All right, so I've got it top and bottom. I've got it going in the X, and I'm going to go ahead and hit apply. Notice along the top here, we've got 7 steps. When you go and do this yourself, you're going to take it might take you a lot less time because you won't be talking like I am going through it. So, all right. With that said, we can move on to the step 2, and here we are with material size and margins. So right now the model size is this blue line right here. The material size is the purple that's out and around it. It's showing you the zero plane, and it's also showing you the size of that material. So for this model, I found it best to work with a piece that is 18 inches long. It is I took it, like I said, I used a 2x4 from Lowe's. So what I did was I put a mic on it and actually mic'd how wide it was. And there's your 2x4. It's really only 3.38 across. So make sure you mic that. 1.5 is the thickness on it. They had it there. And I am going to zero to the top. I'm zeroing to the top for this part. And zeroing to the top helps you keep this accurate as far as getting down into this, and it really helps when you do the flip. So, and notice we've got the XY position in 0, 0. And again, some of this you're going to be asking questions why right now. When we go and show you the videos, you'll see it, and I'll also be coming back to this here in a little bit. All right, so I got my material size. I can hit apply, and you'll see, boom, the material size is now that size. So that's my 2x4 that I've cut. It's that big, and the model's down in here. Why so long? Well, I needed some room for hold down, and I needed some room for some indexing pins. So that's why that's so long. So XY 0, 0. And what's this right here? Machining margins around model. So look at this purple. Let's go around this car. That's allowing you to get down around it. If you didn't have a machining margin around it, how are you going to get down in here and get right here on this edge? If you have that set smaller than the diameter of your bit won't be able to get down there. So if I'm going to use a 1/4 inch bit for this, I'm going to set this just to be a little bit bigger. That way my bit can get down and around this. All right, so that's what the symmetrical means. Otherwise, what you'd have is you could actually set a border all the way around of exactly how you want it. I stick with this. It seems to be a lot quicker, and I've been real happy with that. Cut plane. The cut plane is where your 0 is at right here, as far as is where your middle of your part is. You can move this cut plane wherever, but where we want it for doing a two-sided machining is we actually want it right in the center. That way our bit comes in equally on both sides. However, one thing that you can run into is, what if this thickness of 1.5 isn't consistent all the way through? So that means you wouldn't get all the way through your cut plane unless you added a cut plane, a depth below cut plane, which is actually called a overcut. So for me, I like to give it a little bit of an overcut so it'll cut down past the cut plane. And I go as far as even going 0.2, almost a quarter of an inch down. And what that allows me to do, if you look at the little car on here, it's saying it'll cut 0.2 down past the cut plane. And I like to do that to make sure I cut all the way into my 3D part. When we preview this later, you'll be able to see if it's like right here where I haven't hit apply yet, it's shadowed out. That's not going to cut right there because that's below the cut plane, but it's still 3D detail from the top side. So it's nice to have a down of a cut plane. All right, what do we have next? We have to add tabs. How are we going to hold this wing in here? I'm sorry, this prop in here once it's cut? Because once it's cut all the way around on that second cut, it's just going to fall out of there and break your bit. So what I want to do here is add a tab. And for this being a pretty aggressive little project, I'm going to give it a pretty bulky tab that I can just go bandsaw off afterwards and then clean up with the sander. So I'm going to go 0.4 by 0.4 of a tab. And if you read this here, it'll explain to you how to do the tab. And I might have to. We'll see how well I remember this. So I'm going to click Add Tab, and then you should be able to click on the part of the model where you want to add your tab. So I am going to try to put one right here in the center. There's tab 0. I don't know why they start with 0. And then here's tab 1. So there's a tab on each end. And notice too, you can move the position of these tabs. You could have them centered in the plane. You could have them moved offset of the plane. All depends on what you want to do. So I'm actually going to center mine. Put it back to center and just leave it like that. So another thing that I learned, this is only a 12-inch, or I forget, this was under a 12-inch long size. If you refer back to the big one that I had that was 4 foot long, one thing I didn't do was I didn't put tabs here in the middle. And what happened with this thin blade? It started bowing. So if this was a longer part, I would recommend putting a tab here and a tab here. For this example, I found out firsthand that those tabs were not necessary. Any longer, you'll want some extra tabs. It's a little bit of extra sanding, but it's going to save your part. For another training someday down the road, we've got here slice model, but we'll keep that a whole separate baby. So overcut, I'm happy with. The tabs have already been added. They're 0.4 by 0.4 by 0.4. So far, nothing too tricky. Nothing too tricky yet. So let's go next. All right, we're already on step 3, and a lot of you guys have done this stuff before when you've done your regular 3D carving. So a roughing toolpath. Again, for first-time 3D people, a roughing toolpath and a finishing toolpath are your next 2 steps. What a roughing toolpath is, it's more of an aggressive bit. It's more of an aggressive cut that can come in there and clear material out faster. And you're actually leaving a distance of material, machining allowance. I'm leaving 0.1 of a material on there, and then I'll come back with my finishing toolpath and make that a lot more slower and accurate. Notice I've got a 40% step over. And a lot of you are going to start giving me flack here. I can see it already from Joe and Gary and all these guys. But what I like to do when I do a roughing toolpath, something like this, I don't even use an end mill. I'll actually use the same ball nose that I'll use on my when it's a 1/4 inch or bigger. I'll use the same ball nose as my roughing toolpath that I would use on my finishing toolpath. And the reason for that is I don't have to do a bit change and do a re-zero of Z. So I like to use that same ball nose 1/4 inch for my roughing and my finish. If this was a 1/8 inch tapered ball nose, now that one's not going to do the best job for a roughing toolpath. But when you get up into 1/4 inch or bigger, I do some 1/2 inch ball noses and stuff on some bigger projects, I just rather not change the bit. It won't hurt nothing. So I got a ball nose 1/2 inch, and I need to edit it because it's set for the depth of the finishing toolpath. So I can change this out. Oops, I'm sorry. Got to go in here and change it. So ball nose 1/4 inch. And what I should have done here is, and that this is another training that we have online, is create new. I could create a brand new bit and have just a ball nose for a roughing ball nose. I can call this roughing 0.25 ball nose, 1/4 inch. I'll go 1/4 inch depth per pass, 0.25. Step over only needs to be 40%. For this one, I'm going to go a little bit higher RPM, and that's a little too crazy. I might go 2.5 and 1 on this. And remember tool number 1. Okay, so that is my bit. And I'm going to go down, double check. Rapid clearance gap, that's how high it picks up above the material when it's not cutting. This is the machining allowance. It's going to leave 0.1 of material. That's fine. And then which way am I going to come in at the cut? Well, the grain of this is going left to right in the X. So I'd like to raster along the X. I'd like to go with the grain. I get a nice long cut that way versus going back and forth with a Y. The machine never really gets time to ramp all the way up to speed. So by going back and forth, I'm getting a lot better speed. I'm going with the grain. And here's the tricky part. I got to calculate the top and the bottom toolpath. So here's the top. I hit calculate. The allowance left on the tool is allowance time is greater than 20% of the tool diameter. Okay. It's just talking about me maybe breaking a bit. That was me setting up my toolpath on a whim. So please check back with the training you'll see on their online for tool database and bit selection. Alright, so we see that it's went ahead and generated a toolpath, comes down here past the 0 plane, and I've got the bit being able to get around, all the way around it. And it says it's going to take about 10 minutes for this. So we're fine with that. We're going to switch to the bottom. Now hit calculate as well. And it's going to calculate the bottom. So you got to calculate both the top and the bottom toolpath at this point. So you got to make sure you do both. Otherwise you'll get to the end and you only have one side, and then you'll go out and cut it and you're not going to have the other side of it. So the calculation bar is going along the bottom here, and that should take approximately the same amount of time. Yep, it did. So next thing here, I'm going to hit next because I've finished with my toolpaths, and we can always come back and change these, and we might have to here in a minute. We'll see. And next is I want to do a finishing toolpath, and I want to use the same exact bit, but I want to use it with some different parameters. So I'm going to go select, and I just made a roughing ball nose right here, and I based it off this ball nose, which was actually my finishing ball nose. And I've got a little bit smaller pass depth because I'm going to go a lot finer. I'm actually going to take this down to 9%. All right, and I'm going to go a little bit faster on this. gonna go 5 and 5. I'm doing a 3D here. I like to keep it quick. And again, I'm only taking off 0.02 every pass, so I'm not doing much wear and tear on that bit. So I'm going to stick with that. There is a rapid clearance gap, but notice there's no tolerance as far as how much material to leave. We're actually making the finished toolpath. I would like to raster along the X. And notice I do have it as tool number 1 as well, because I don't want the machine to prompt me and ask me to do a bit change. I want it just to pick up after the roughing and go do the finishing. And I am going to hit calculate for, I got to do the bottom and the top again. So calculate bottom. If you ever notice too along here your blue thing not going fast like this, calculating, like it's really moving slow, come back up and check your parameters. Sometimes I've seen people have this where it says 5 inches a minute versus 5 inches a second. So you're really cutting slow then. So six minutes to do that. And I got to switch over to the top and hit calculate there. So yeah, this one is actually taking less time than the roughing. The roughing is auging out quite a bit of material. So this one's just making that one last finished pass, even though it's a lot less step over. It's not making as near as many Z different heights of cutting. All right, finishing toolpath, check. Cutout. We're not doing a cutout. The 3D part of it is actually taking all this material around it out. So there's no reason to do a cutout at this point. So I will hit next. And here's where we can preview and make sure that we're happy with what we just calculated. So I'm previewing, and notice I'm previewing the top. Down here in the bottom left it says top. So it's making quite a few passes there to get through the roughing. And I look on the bottom, see nothing's been done yet. So let's go back to the top and let's do the finishing toolpath. See how this one's a lot less step over, but it's giving you that finished look. It's pretty awesome. If you haven't done this yet with a ball nose, get a 1/4 inch ball nose and try this out. It's pretty cool. It really is. So we're seeing some tabs, and this is where when I first started doing this, I zoomed in right here and I could see a flat spot on the bottom of this wing where it dips down. I said, where is that? What is coming on here? I didn't get it at first. And sure enough, I didn't have that cut below zero plane, because this part of the wing right here, this part of the propeller, is actually below zero. So you had to have that step down to go down and cut down in there a little. And it didn't hurt. All I did was cut down a little bit extra around my part. No big deal. I'm going to do the same thing on the other side, and it does not affect the tabs. So with that said, let's check the bottom and see how I did here. So let's do the roughing. And eventually that roughing should get down where we should be able to see some of the other side through it. And boom, there we are. We're down into bringing it out. So right now, we still have a toolpath to do, and we're just being held in place with tabs. So a short little part like this, no big deal. But if this was that long propeller that I showed at the beginning, the 4-footer, you'd want some tabs here in the middle as well. So there we go. It's that easy, right? Drawing it and toolpathing is pretty easy. And it looks great. It does. It looks good, and it's pretty cool. So the question for us now today is, how do we get this on the ShopBot and have it line up, flip it upside down, and have it line up with the other side? So we will marvel in our madness here before we move on. So at this point, this is where I would go ahead and save this toolpath. So the way you save these are, in the next step, you have a roughing and a finishing that you can save, or you can go save toolpaths to a single file. And notice when you do that, it's just either saving the bottom or the top. So I like to save both to a single file with the same bit. If you're doing a bit change, you might want to not do this, but doing that same bit, you are able to go save toolpaths to a single file. And there's bottom, so I'm saving the bottom, and we'll just put this in the folder as prop bottom, and save it. And now I got to switch it over to top and go save toolpaths to a single file. I want my roughing and my finishing to come through as prop top, and we got prop top. So save. So take a deep breath. We got the first one done. We've got our toolpaths done. Now we just got to figure out how to get it onto the machine. So let's look way back here to step 2. Where did we zero this part? We zeroed it in the middle of, we zeroed it right here. It's zeroed in the middle of my material. So my material is 18 by 3.38, which is this outline right here. And then this is the size of the cut right inside here. So this right here is the size of the board that I'm using. I'm also going to make a either Partworks file or a VCarve Pro, depending on what software you're running, of this too, because I have to do with my indexing pins into the table. So what I want to bring up here is my VCarve Pro file. So here's a file that I created, just a 2D file, and this should, let me try to split the screens here. These two should kind of resemble each other as far as the white block here is the size of the 2x4, and then this rectangle in the center is the size of the cut. Here would be the size of the 2x4, and here would be the size of the cut. So what I've done is come in here to this drawing, into this VCarve Pro. I've typed in the same dimensions that I made my 3D model in, zeroed it to the top, and what I've done in here is all I've done was make these 2 holes, is what I want accurate. I need these to be centered in the center of my material. So instead of having our 0, and this is where it's going to get a little bit tricky. This is where we're recording this. We can come back and watch it. You can pause it as you're trying it and going back and forth. And again, once I go through it once, we'll go back and kind of slow down and go into it a little bit more. For me, the way I tried this and got it to work was I put 0, 0 instead of the bottom left corner of the part. It's now in the middle of the 2x4. And as we go through and watch these videos, you're going to see why this works. So it's 0, 0 in the middle on our 3D. It's 0, 0 in the middle of this. And we have to now 0, 0 it out on the machine. So if we bring up a ShopBot control software, and we're at 0, 0, which is we do our C3 of our proximity switches, it brings it to the bottom left corner. Well, how do I get it to where 0, 0 is in a different spot? Well, for us using a desktop, the way I had it on my desktop here was I knew that I wanted to go halfway across the desktop, which is 24 inches. And I knew that I wanted to bring it back a little ways into the material. So it didn't matter quite where I put it as long as it was back on the thing. And I'm going to show you a video of it here first. So the first thing first, let's bring you up the better one. To hear all the background noise. First things first, instead of 0, 0 being right there, I brought it out into the table right in here where I could work off a 0, 0 point. So this would be doing a jog 2 axes to, again, I think I took it, if this was 24, I probably went to 12, and I probably went 2 inches back. So at that point, with your machine here, you would go jog 2 axes, and I went 12, 3, and then the machine goes ahead and moves back there. Now the problem is our ShopBot does not know that's what we want it 0, 0 right there. We have to tell it that that's where we want 0, 0 because that's where we have it in the file. So I went up here and go 0, 2 axes, and as we do this, this X and Y are going to change to 0, 0. So bang, we've just made our new temporary 0 out in the center. All right, another thing that I recommend doing is making a 0, 0 grid with 2 lines. Take some drawing lines and snap them at 0, 0, toolpath it, and have it just come out a little bit past. And let me show you the video for that one. I'll close a few things so we don't I don't want us to lose communication here. So the next thing we'll do is take the machine, put a V-bit in it, and what it's going to do is it's drawing an X into the table. I'm sorry, a set of crosshairs. So it's drawing those crosshairs in there, and this is going to help me line up the board. All right, so when that's done, then take a marker, a Sharpie, and fill in that line right there. See, there's me just drawing it in. Now I'm taking my board, and I've made a line in the center of the board, and I made a line on the end of the board in the center. So when I set those down in there, that's all we have to do is get it right by eye right now. We haven't drilled any holes or anything. So this is all just off eye. So center 0, 0 is right here in the middle of the board. Let me play that one once more. Here's 0, 0 in the table. It's 0, 0 because we did a Z2 in the ShopBot software. We drew this at 0, 0, and we also made our indexing holes based off this 0, 0 coordinate, not being in the bottom left, but being in this new position. So this is called a temporary offset, a temporary 0. So with that being said, when you get through to that part, what you'll want to do is come back into this file here, and this is where you can delete the left and right X's. You don't need those anymore. And what you'll need at this end is a toolpath that will go and drill these holes. For this, I used a couple 3/8 dowels, and all this is taking these 2 dowels, and I'm going to drill a hole and a hole on each end into the spoil board. That's what that thing is there for. It's the sacrificial board. It's there to sacrifice itself for you. So take your Z0 plate and 0 it to the machine bed, and then go over here and drill those holes. See how they're set right off the center of the X0? So drill those holes into the spoil board. We're going to need those indexing holes when we flip it. So as long as those holes match the holes in the top of the board, we're fine. So with that being said, run those holes in, and now we want to put our part on the machine. So we just did this into the spoil board. What we want to do next is set our part back onto the spoil board, and the first thing we want to do is re-zero our Z to the new height, which is on top of the board itself, on top of the 2x4 or whatever it is that you're going to use. And finally, you'll have to hold that down. Note we have not used any indexing pins so far. So there, I'm just putting a screw in each end. I've laid that out so I know it's not where I'm going to cut into, and I know it's not where my indexing pins are. And then I'm going to re-zero with the 0 plate off the top of that. All right. Once you have re-zeroed it off the top, this is the part where you will run that same file of indexing holes down into the top of your board. So now you're cutting those into the top of your material. And they're going to line up exactly with the holes on the bottom because we haven't made any adjustments at this point. We've already zeroed it. Where this board is held in place just by eye with these lines is fine, because the file is going to cut off center right now, off the center of the part. And as we flip it, it's going to still be in the center now on the other side. So I hope we're doing all right, following along. I'm going to keep going here. So with that being said, we've now held down, we're zeroed, and we've indexed the machine bed and the top of this part. At this point, I would say go ahead and file part load. And I'm sorry, we would go file part load, and that's where we would find our top. We want to do our top first, because that's what we're doing is the top. We would run our top, and you'd go ahead and let that run, but I'm not going to run it so we can watch the video. Here it is running. Now notice on one thing here. What did I say earlier? This board in this example, when I filmed this, wasn't the full 3.5 inches wide. It was 2, just wider than the part. And note my bit will be sticking out over here. And sometimes when it's making a really aggressive cut, see these chips and chunks over here in the end, this blowout? You won't get that with a wider board. So that's where it's nice to have a wider board than having that bit hang out on the end there. And it's just going to keep working back and forth. And again, I've got my dust collector off so we can actually see what's going on. You want to have that thing dust collecting. And since I used the same bit, I didn't have to do a bit change or do any re-zeroing. And now it's doing the finishing toolpath, and I don't have to take the chance of not getting my heights right with the re-zero. There it is. And I should zoom in here in just a second. You'll see it doing the finish toolpath. Look how it's going from rough to finish. Just like that. If it only had cut just like that, there, that fast, I've got it sped up a little. This took about, I want to say about 15 to 18 minutes, depending on your setup. Is what that will take to do that side. So boom, there was side 1. That was the top side. And so we get done with the top. Now we've got to flip it. So this is where people go. This is where people make the mistake, because how do you index this thing completely upside down? So this here, we're all done with the cut. Move it out of the way, and we've got a screw. We got a screw on each end, and we got to clean it up. Any dust or debris left on the machine bed will throw off your zero. So once you get this thing unscrewed, I would vacuum it off and blow it off. And also make a mark here so you know what end is facing the zero end. Because what you want to do is you don't want to accidentally index it over to this side. That's not the way we're flipping this part. So we know maybe you should put I put the X there because I know X is usually what I refer to over where the original 00 is. But I know that needs to stay on that end. So I've taken the screws out, and once the screws are out, I've done nothing, but I'm just flipping it over. The screws are out. I go ahead and I put a pin in there, and I put a pin in that side. Move it out of the way, and all you're doing is flipping it over from face to face. There's those pins in the table. So now that center lines exactly up with the center of those pins, and you have just successfully flipped this thing 100% over on itself. So you got to hold it back down. Those pins are just there for location. They have nothing to do with holding it down. So get a good hold down system. For that, a screw worked great on each end. All right. Next thing we got to do is machine the bottom. So the machine the bottom, it's the same thing here. It's the roughing toolpath, but let me pause it. Notice this blowout here, this tear out. It was taking out big chunks. Well, depending on the type of wood you have or the grain, that could be a big enough chunk that one could shoot out and snap a bit. It could catch and make you lose position. So I like to have a wider board. A lot wider than the part, so it stays within the board. That's just preference I have. have after cutting this. Realized a wider board works good, and I'll show you the big prop at the end once more. So the roughing really is pretty vicious. Look at all the big chunks it takes off. This popple being real stringy stuff, it just grabbed it on. And that blowout was pretty bad on the sides. So the next time I did it was with a 2x4 that was wider and just centered it on the 2x4. All right, and then here we are. That finishing, I just love watching finishing Toolpath. How it makes it, cleaner than I could sand it. It's just, it's great. All right, so now we have machined both sides. We've got screws holding it to the table, and we have tabs that are oh, sorry about the sound. There's the finished part. That's what it looks like all done. And I'm sorry I skipped videos there. It should have been number 10. We got to pull it off before we can take a look at it. Getting all excited here. I was so happy on how well I did. So we move it off. We unscrew it. We could always put it back on if we had to, as far as machining the bottom, because we've got the indexing pins. And we could always drill holes in the top and flip it back over if we had to. So that's really it. And here again is the final part when it's brought off there. And I just cut it off. There's the tabs on there still. There's a little bit of sanding that needs to be done on the edges. But that was a two-part flip. And just to show it to you once more, I'll walk through it. This is the bigger one. This is the one I showed right at the beginning. Just a recap. We take our material, know the dimensions of this, because that's what you're going to draw it in. Have a nice flat top for it to be machined flat so you can do a flip. Go through and do the PartWorks 3D. Make sure you're doing both sides. Make sure you have an overcut. So you have a file like this where it needs to actually cut down below 0. You got to have tabs. Something that I did as a no-no on something that's 4 foot long in between here, you should have had tabs in the middle to suspend it. That thing started wobbling, and I had to end up putting some pieces underneath it and some shims while I was cutting. Indexing pins is what you cut first. So take your file and zero it to the machine bed. And what you do is zero it to the machine bed and cut the holes into the machine bed. Screw down your part. Cut those same indexing holes in the top of your part. Now do the toolpath of the top side. You'll start out with your roughing. You'll get into your finishing. Move it out of the way. Flip it. All we're doing is flipping it from face to face. We're not flipping it end to end. Use our indexing pins. That'll get it right back on that 0, 0 center line. You have to hold it back down. The pins are just there for location purposes. And then same thing. Finish it up, and then there's your finished part once you've cut off the tabs. So just remember, you'll be using PartWorks 3D, and you'll use a VCarve Pro or PartWorks 3.5 file, and make your 0, 0 right here in the center. Have these indexing pins lined up with 0 and the X, and you'll be able to flip all day long and get the results that I got. So mess with your feeds and speeds. Let me know. We'll put the file up for this too. A 2x4 works the best. You can go. It's cheap and easy. Go get an 8-footer. Cut it down into 18-inch lengths, and you'll be able to cut several of these in practice before you go and find your nice piece of maple or walnut. So with that being said, thank you. I'm going to stop the recording now, and we'll start the Q&A portion. And I hope this was helpful for everyone.